Terima kasih. Oke, terima kasih Bapak Andi Chandra atas sambutannya yang sangat hangat. Baiklah, hadirin acara kedua kali ini, sebelum kita lanjut ke sesi berikutnya, saya ingin menginformasi bahwa bagi peserta yang memiliki pertanyaan dapat mengisinya melalui Google Form yang disalurkan atau barcode-nya telah dibagikan oleh panitia. Silakan isi form tersebut dengan pertanyaan yang ingin diajukan dan ingin nantinya akan dibacakan pada sesi tanya jawab. Baik, dengan itu tibalah saatnya kita beralih ke acara inti. Marilah kita sambut bersama Ibu Stephanie Yesi dari Nestle Indonesia.
Halo pagi semuanya. Pertama-tama saya mau mengucapkan selamat pagi untuk Bu Juli dan juga Pak Andi dan teman-teman semuanya di sini. Perkenalkan, nama saya Stephanie Yesi Puspita, biasanya saya dipanggil Yesi. Oke, topik hari ini saya akan memberikan sedikit basic pengenalan terhadap tentang packaging. Saya akan membahas tentang structure, function, sama mengenai shelf life. Agendanya pertama saya akan melakukan introduction, kemudian topik kedua itu kenapa sih packaging itu penting, kemudian ketiga itu packaging classification, keempat itu packaging tipe-tipe packaging berdasarkan strukturnya, kemudian rigid plastik, mengenai rigid plastik, kemudian selanjutnya itu mengenai flexible packaging, kemudian step-step kalau di dunia industri pengembangan packaging itu seperti apa sih step-stepnya, kemudian selanjutnya bagaimana kita menentukan material packaging saat untuk menentukan material packaging, kemudian selanjutnya mengenai shelf life. Shelf life itu adalah berapa lama sih produk tersebut akan bertahan atau expired date, dan juga menentukan performance packaging untuk memastikan bahwa packaging tersebut dapat memprotek produk yang ada di dalamnya. Kemudian yang selanjutnya akan ada Q&A. So, dulu saya di teknik kimia angkatan 2005, kemudian lulus di Januari 2010. Waktu itu saya sebenarnya anak bimbingan Ibu Judi waktu di semester pertama, tapi setelah itu Ibu Judi harus ke Belanda kalau tidak salah untuk melanjutkan doktor ya Bu saat itu. Kemudian waktu penelitian saya sama Bapak Tony Handoko, dan saat rancang pabrik itu dengan Pak Andi Chandra. Ya ini waktu saya di Unpad. Kemudian mengenai karir saya memulai dengan karir saya di Danone sebagai SAP Master Data Analyst selama 1 tahun. Kemudian di tahun 2012 saya pindah ke Business Planning Analyst, itu Finance Division. Karena saya merasa itu bukan tempat saya, karena saya merasa saya anak teknik, saya jadi berusaha untuk mencari posisi yang lebih tepat untuk saya. Jadi saya pindah ke Pease & Cousins di posisi Packaging Development Manager. Saya kerja di Pease & Cousins selama 10 tahun, kemudian tahun 2024 saya pindah ke Nestle dengan posisi yang sama, yaitu Packaging Development Manager. Di Nestle saya menghandle beberapa kategori, yaitu coffee, kemudian food, Nestle Professionals, dan Nestle Health Science. So, pertanyaan pertama saya, kira-kira kenapa sih kita butuh packaging? Ada yang bisa bantu saya menjawab? Kalau ada yang bisa jawab, saya punya hadiah.
Selamat pagi Ibu. The question is, what would it be without packaging? I think it'd be very messy, and food would spoil quickly, and yeah, just overall messy. And I think many of the foods that require packaging, it would spoil quickly, and it just lead to an overall deficiency in food sources.
Ada yang lain yang bisa melengkapi mungkin?
Oh, and also to prevent contamination.
Yang mau menjawab lagi? Oke, karena cuma hanya satu yang jawab, jadi yang dapat tadi satu orang. Kenapa sih kita butuh packaging sebenarnya? Ya, ada beberapa jawaban yang benar. Kalau enggak, repot banget ya. Gitu. Kalau misalnya susu, gimana dong? Mau minumnya masa mau minum langsung dari sapi gitu kan. Kemudian kalau takaran, misalnya kita beli beras, misalnya beli 1 kilo, gitu. Gimana mau tahu 1 kilo itu takarannya seperti apa? Kemudian packaging itu apa sih? Jadi packaging itu adalah suatu wadah yang bisa melindungi produk tersebut. Kemudian dia ada beberapa function. Yang pertama physical protection. Jadi packaging itu untuk melindungi yang ada di dalamnya. Nah, yang kedua barrier protection. Jadi dia memastikan bahwa produk yang di dalamnya itu tidak terkena kontaminasi, baik dari misalnya dari mikroba, atau dari exposure dari sinar matahari, atau dari oksigen. Jadi misalnya kalau misalnya makanan terkena oksidasi, dia akan cepat basi gitu. Jadi dia memberikan protection. Selanjutnya itu agglomeration. Ya, jadi dia suatu wadah untuk dia seperti yang tadi saya bilang, supaya dia bisa terkumpul jadi satu. Yang kedua untuk communication, jadi pastinya tim marketing akan memberikan komunikasi, bisa menjelaskan produk ini untuk apa, fungsinya seperti apa, manfaatnya seperti apa. Kemudian yang selanjutnya itu marketing and brand image, jadi kalau misalnya for example coffee gitu, seperti apa sih image dari produk tersebut, apa sih marketing yang ingin sampaikan terhadap consumers gitu. Yang selanjutnya sustainability, jadi supaya terjadi sirkulasi, supaya dia tidak mencemari lingkungan. Selanjutnya untuk customer convenience, supaya customer itu merasa nyaman atau convenience saat dia mengkonsumsi produk tersebut. Selanjutnya cost efficiency, jadi gimana sih kita menciptakan packaging dengan cost yang efisien. Selanjutnya packaging classification, jadi berdasarkan klasifikasinya packaging itu ada 3, yaitu primary packaging, secondary packaging, dan tertiary packaging. Apa sih primary packaging? Primary packaging itu adalah bagian packaging yang kontak langsung dengan makanan. Sedangkan yang kedua itu adalah fungsinya secondary packaging itu adalah dia yang melindungi atau memberikan pengelompokan, misalnya nih ada beberapa saset. Kalau saset kan misalnya ada 10 saset. Jadi company itu mau menjual dalam satu pouch. Nah, pouch yang di luarnya itu disebut secondary packaging. Jadi primary packaging itu adalah sasetnya sendiri yang kontak langsung dengan produk di dalamnya. Secondary packaging itu adalah pouch yang ada di luarnya. Contohnya seperti itu. Atau misalnya kalau kalian beli air mineral, kemudian ada yang bisa beli pack, misalnya 4 botol dalam satu pack atau 6 botol dalam satu pack, kemudian dia akan ada wrappingnya lagi. Nah, wrappingnya yang di luar itu disebut dengan secondary packaging. Sedangkan tertiary packaging itu lebih untuk logistik atau warehouse, karena kan kalau misalnya di industri produk-produk tersebut harus disimpan di dalam gudang dan harus didistribusikan. Nah, jadi karton boxnya itu yang di luarnya itu disebut dengan tertiary packaging. Nah, berdasarkan strukturnya, packaging tersebut dibagi menjadi 3. Yang pertama itu adalah rigid packaging. Rigid packaging itu yang kokoh, yang keras, gitu ya. Contohnya seperti botol, kaleng, kemudian gelas kaca, gitu. Itu rigid packaging. Kemudian yang kedua ada flexible packaging. Flexible packaging itu yang agak lentur, gitu ya. Seperti misalnya saset, standing pouch, kemudian wrapper. Misalnya kalau kalian punya tisu basah, gitu ya, itu disebut flexible packaging. Kemudian yang ketiga itu semi-rigid packaging. Semi-rigid packaging itu adalah combination between rigid packaging dan flexible packaging. Contohnya seperti apa sih? Misalnya kalau kalian beli susu, ada Tetra Pak untuk susu, itu disebut semi-rigid packaging. Atau misalnya blister obat, itu juga semi-rigid packaging. Nah, berdasarkan packaging material, itu penggunaan yang paling besar material tersebut yang pertama adalah plastik sebanyak 45%. Material yang kami digunakan yaitu adalah PET, HDPE, PP, dan PS. Sedangkan yang kedua itu adalah glass, yaitu sebanyak 25%. Biasanya dia digunakan untuk alkohol atau misalnya untuk saus atau untuk susu, gitu ya. Kemudian biasanya dipakai juga untuk premium kosmetik sama untuk obat. Yang ketiga itu adalah metals. Biasanya metals itu digunakan untuk beverage, aerosols, misalnya buat perfume, atau untuk food cats atau binatang, makanan binatang, makanan kaleng. Kemudian ada tin plate, biasanya untuk powdered milk, misalnya kalau kalian tahu beer brand, itu contoh dari tin plate. Yang terakhir adalah paperboard. Paperboard itu contohnya misalnya ice cream box atau cosmetic box. Kalau kalian beli kosmetik ada boxnya itu materialnya paper. Atau kalau kalian beli snack kayak Pringles, kan, itu juga composite paper. Nah, rigid packaging. Yang paling common itu adalah PET. Proses bikin botol PET itu seperti apa sih? Gitu. Nama teknologi untuk membuat PET bottle itu disebut ISBM. Apa sih ISBM itu? ISBM itu adalah Injection Stretch Blow Molding. Jadi resin PET dipanaskan, kemudian di-injection, kemudian dia akan di-stretch dalam bentuk freeform. Freeform itu bentuknya agak unik, kecil gitu ya, kalau bisa dilihat seperti itu. Kemudian dia ada yang 2 stage, ada yang 1 stage. Sorry, ini harusnya dia 2 stage. Jadi kalau 1 stage itu dari resin sampai ke botol itu dalam 1 cycle, jadi 1 proses. Jadi dari resin dipanaskan, dibuat menjadi freeform, kemudian jadi dari resin, kemudian diinjek, kemudian dia dibentuk menjadi PET freeform, kemudian PET freeform ini dipanaskan. Setelah dia dipanaskan, dia akan ditarik gitu ya, ada seperti cup metal di sini ditarik gitu ya sampai ke bawah gitu kan sini. Kemudian ditiup dengan menggunakan air pressure. Kemudian di sini ada namanya molding. Jadi kayak cetakan botolnya. Jadi mau kalian mau bentuk botolnya seperti apa? Kemudian setelah dia membentuk botol dengan sempurna, baru dia akan dilepas moldingnya. Jadi seperti satu botol. Ini yang 1 stage. Kalau 2 stage itu seperti apa sih? Jadi dia dari resin, kemudian diinjek dulu menjadi preform, kemudian setelah jadi preform dia nggak dilanjutin ke proses ini, dia disimpan dulu, kemudian nanti dia ada another station untuk melakukan proses ini. Itu perbedaan antara 1 stage dan 2 stage. Selanjutnya itu rigid packaging HDPE bottle. HDPE bottle itu seperti apa sih? Misalnya kalian bisa temukan di botol-botol susu atau botol obat atau botol lotions gitu ya. Kalau PET kan botolnya clear seperti botol air mineral, itu adalah botol PET. Tapi kalau HDPE biasanya dia warnanya itu seperti tidak transparan gitu. Jadi dia warnanya kalau base-nya HDPE itu kan white ya, jadi kayak dia lebih opaque. Nah, biasanya bisa dikasih coloran, bisa berwarna-warni. Biasanya aplikasinya itu dipakai untuk susu, bisa jadi susu atau kosmetik. Kemudian prosesnya itu agak sedikit berbeda dengan PET bottle. Kalau misalnya HDPE bottle, prosesnya itu disebut dengan extrusion blow molding atau EBM. Seperti apa sih? Jadi dari resin, HDPE resin, dia akan dipanaskan dan diekstrud. Jadi kayak ada extrusion. Nanti ada videonya. Jadi resinnya setelah dipanaskan, dia akan dialiri, dia mengalir menjadi cair kan. Dia akan dialirkan. Kemudian dia akan masuk ke sini menjadi bentuk seperti parison. Parison itu kalian bayangkan seperti selang. Tahu kan selang plastik itu lurus gitu. Dia lurus, materialnya itu akan menurun lurus. Kemudian di sini sama ada moldnya, ada cetakan botolnya. Dia akan lurus. Kemudian setelah dia nyampe di sini, dia akan tutup. Moldnya akan menutup. Kemudian akan ada air pressure juga dari sini, akan di blow, akan ditiup sampai si material plastik ini memenuhi cetakannya menjadi botol seperti ini. Gitu. Nah, kalau tadi ini kan karena ada bentuknya di sini kan, seperti selang tadi, karena dia ikutin bentuk moldnya, jadi bagian bawahnya itu atau bagian atasnya ini ada ekses material di sini, ekses material, ada kayak material berlebihnya, jadi dia otomatis akan terpotong. Jadi nanti di sini dia akan otomatis ada cutternya, akan dipotong supaya dia bentuknya itu lebih halus. Di sini juga nanti di sini setelah dia terbentuk dengan sempurna, moldnya akan terbuka dan ekses dari material tersebut akan terbuang dengan sendiri, akan terpisah.
extruder. Heating elements ensure that the material reaches the perfect melting point. The extruder screw pushes the molten plastic through the barrel while maintaining the ideal temperature. Moving on to the extrusion head, this is where the magic happens. The molten plastic enters the extrusion head and then flows and splits into the mandrels. As the molten plastic flows over the mandrels, it takes shape and forms a hollow tube or parison. Thanks to the wall thickness control, the thickness of the parison is regulated by adjusting the distance between the die and pin. It takes center stage, ensuring the perfect thickness of plastic in every inch of your container. A key component in this system is the adjustable dial.
Jadi
It
ketebalan
holds
botol
the power to
itu
shape and
diatur oleh
distribute the thickness
kedua
of the
ini,
extruded
pin
parison.
ini. Jadi kalau dia
It's
makin tekuk,
adjustable, allowing for that
berarti
meticulous
botolnya makin
fine
tipis.
tuning
Kalau dia
of the
botol
wall
makin
thickness.
jauh, berarti ketebalan
By
botolnya
increasing the
lebih
wall
tebal.
thickness in the head and bottom regions, we enhance the stability of the article while saving material in the central area. This not only improves performance, but also makes the blow molding process more cost effective. So, whether you're producing hollow plastic containers, the wall thickness control system is the hero behind the scenes. For maximum productivity, some machines employ a twin station setup, allowing for double the output. Now, let's explore what happens after the mold closes. Compressed air is used to inflate the parisons through the blow pins. This causes the plastic to expand and take on the shape of the mold. Through the water cooling of both mold halves, the article sets and solidifies immediately. The punching device ensures the removal of any excess material around the neck and bottom areas. Embracing the circular economy, our process reuses process, flash, and incorporates post-consumer recycled material.
Nah, kita sekarang ke flexible packaging. Flexible packaging itu apa sih? Tadi yang saya bilang ya, dia fleksibel seperti kertas ini. Dia lentur. Nah, flexible packaging itu kalau kalian lihatnya cuma kayak seperti satu lembar plastik aja kan. Tapi sebenarnya flexible packaging itu terdiri dari beberapa lapisan. Jadi lapisan pertama itu printing layer. Jadi kalau kalian lihat seperti tadi ada di bagian tempat tiket atau kafe kan, di luarnya ada printing. Jadi layer pertama itu untuk printing. Yang kedua itu adalah barrier. Barrier itu apa sih? Barrier itu untuk melindungi produk yang di dalam dari kontaminan dari luar. Gitu. Biasanya material untuk barrier itu bisa dari aluminium, bisa dari nylon, bisa dari metallized PET atau metallized PP. Kemudian di bagian dalam yang kontak dengan food itu berfungsi sebagai seal. Seal itu apa sih? Supaya laminate tersebut saat waktu dibentuk dia bisa di seal itu seperti apa ya, di press apa ya kalau kalian apa sih itu namanya, kalau plastik sama plastik biasanya kalau kertas dilaminasi supaya bisa dilaminasi gitu biar bisa menempel, bisa menutup. Jadi sebenarnya plastik yang kalian lihat flexible packaging itu tidak sesederhana hanya satu material, tapi dia terdiri dari beberapa layer plastik yang memiliki fungsinya masing-masing, kemudian akan dilaminasi bersamaan, kemudian membentuk jadi satu packaging. Keuntungannya apa sih? Dia bisa gampang dibentuk, kemudian dia juga lebih murah, kemudian juga bisa dikombin dari beberapa material menjadi satu material yang memiliki fungsi yang berbeda-beda. Kemudian yang selanjutnya itu dia lebih ringan atau lightweight dibandingkan dengan si rigid packaging. Selanjutnya, yang paling penting mechanical properties itu apa sih? Secara mekanikal yang paling penting itu adalah tensile strength. Jadi karena dia tadi terdiri dari beberapa lapis, yang paling penting itu supaya lapisan tersebut tidak mudah dipisahkan. Kemudian yang kedua estetika. Jadi gimana supaya dia memiliki teknologi atau visual yang sangat baik. Yang ketiga barrier. Yang paling penting itu barrier supaya dia bisa memproteksi produk yang ada di dalamnya. Yang keempat itu sealability. Jadi supaya produk tersebut bisa di-seal dengan baik sehingga tidak terjadi kebocoran. Gitu. Kalau ada terjadi kebocoran, produknya bisa keluar, bisa leaking atau bisa terjadi kontaminasi. Nah, prosesnya itu pembuatannya seperti apa sih? Kalau di dunia packaging, di industri, yang pertama itu tim packaging seperti saya itu akan menyiapkan technical drawing. Jadi technical drawing itu dibentuk seperti bentangan seperti ini untuk menentukan area teksnya yang mana, area untuk brandnya itu di mana, untuk expired date itu akan diletakkan di mana, dan lain-lain. Yang kedua, nanti tim marketing akan menyiapkan desain. Yang ketiga itu pre-press dan cylinder making. Jadi kalau misalnya di dunia flexible packaging itu mereka ada proses printingnya. Yang keempat itu ada proses printing. Yang kelima itu laminasi yang seperti saya tadi jelaskan karena dia terdiri dari beberapa lapisan. Jadi mereka harus dilaminasi. Yang keempat ini adalah additional. Kalau misalnya di industri itu ada dua. Apakah supplier itu akan mengirimkan dalam bentuk roll atau dalam bentuk dia sudah dibentuk atau dalam bentuk preform. Jadi kalau misalnya di supply-nya dalam bentuk preform, maka akan ada additional proses di sini, yaitu proses pemotongan dan bag making. Kemudian ini salah satu proses printing teknologi. Jadi gimana sih packaging yang ada di depan kalian supaya bisa ada printingnya tersebut? Yaitu salah satunya adalah rotographer. Jadi rotographer itu apa sih proses printing? Dia itu menggunakan plat silinder. Jadi platnya itu bentuknya seperti ini, metal. Jadi dia di-engrave bentuk kayak pakai laser gitu, sehingga dia ada titik-titik kayak lubang-lubang kecil yang akan membawa ini. Jadi dia bentuknya kayak mangkok kecil-kecil gitu, dia akan membawa ini. Kemudian dia akan kontak membawa ink, kemudian kontak dengan material substrate packaging tersebut, sehingga dia akan mentransfer ink tersebut ke permukaan plastiknya. Ini salah satu contohnya. Saya punya waktu berapa menit lagi? Sorry. Saya harus cepat. Berapa? 30. Oh, 30 menit. Ini bukan yang gini. Yang rotographer. Satu slide sebelumnya. Nah, ini salah satu mesin printing flexible packaging. Mesinnya itu gede banget, bisa satu ruangan ini gedenya.
Reaching a top speed of 600 meters per minute and printing width of up to 1500 millimeters.
It is the top solution for medium runs and multi-purpose printing applications. The 6003 press is operator-friendly and packed with innovations and on-demand enhancements.
Jadi kebayang nggak, speednya itu cepat banget, bisa 900 meter per menit. Cepat banget, mata manusia itu nggak akan bisa melihat.
The great twin trolley technology for fast and flexible job changeovers.
Nah ini silinder-nya tadi yang saya bilang untuk mentransfer dari ink ke packaging materialnya.
Accessibility to all areas of the machine. The 6003 also introduces Bobst's innovative twin flow drying system. Gently blowing air onto both sides of the web to reduce the skin barrier effect and maximize solvent evaporation. The dual drying system creates minimized turbulence for optimum web handling and less energy consumption, making this the most efficient drying solution on the market. Removing the drying nozzles is effortless, and the full accessibility design makes all maintenance activities simple for the operators. The machine is engineered for fast and simple job setup. The twin trolley and chucking system design further improve flexibility and reduce preparation times. With attention to detail and integrated technologies, all phases of preparation are geared to facilitate operations and reduce waste and downtimes in full safety. TAPS is Bobst's pre-register system. One touch of a button to completely and automatically register the machine with minimal startup waste and in minimal time. The integrated registrar provides unbeatable register accuracy, even at high acceleration and on
Proses
difficult
printing itu
substrates.
nggak kayak yang tidak sama seperti printer. Kalau printer kan begitu keluar gambarnya langsung sama kan. Tapi kalau mesin printing di packaging itu dia berdasarkan color by color. Jadi warna kuning dulu, warna biru dulu gitu. Jadi dia kalau dilihat ada beberapa station. Jadi satu station itu satu warna. Jadi warna kuning dulu, warna biru dulu, warna ungu dulu, warna merah dulu, nanti sampai keluar terakhir. Jadi full picture seperti yang
Easy operation,
yang kita mau.
high-class printing. Choices made simple.
Nah selain rotografer itu biasanya digunakan untuk apa sih? Biasanya untuk produk-produk yang volumenya itu dalam jumlah yang tinggi. Jadi karena dia high speed, sehingga secara cost untuk volume yang besar, kalau dibagi per piecesnya dia jadinya lebih murah gitu. Sedangkan kalau yang satunya, itu flexograph. Jadi kalau flexograph itu dia, kalau yang tadi kan rotografer dia menggunakan flat metals. Kalau misalnya flexograph dia menggunakan rubber. Kalau yang tadi rotografer itu silindernya metal kemudian di engrave. Jadi di laser gitu Bu. Jadi bentuknya itu akan seperti mangkok-mangkok di dalam itu. Jadi kayak ada bolong-bolong itu yang akan membawa ink. Tapi kalau flexograph itu kebalikannya. Dia terbuat dari silikon, tapi dia muncul kayak cap, tahu kan? Kayak cap. Jadi dia timbul. Sehingga nanti yang bagian yang timbul itu akan kontak dengan ink, kemudian dia akan diputar, kemudian ada material yang lewat sehingga mereka akan bertemu, akan kontak, sehingga inknya itu akan pindah, akan transfer dari rubber tersebut, dari platnya tersebut ke packaging materialnya. Nah, kalau flexograph itu bedanya dengan rotografer. Kalau rotografer itu kualitas printingnya itu bisa sangat bagus, sangat tajam gitu. Seperti yang packaging yang kalian lihat. Bisa benar-benar kayak apa ya? Kayak 3D, kayak hidup gitu, kayak benar-benar detail. Tapi kalau flexograph, sometimes dia nggak bisa sebaik seperti rotografer gitu. Dan biasanya kalau rotografer itu high speed. Kalau flexo itu dia tidak secara cost untuk yang volumenya tidak begitu besar, dia akan lebih efisien dibandingkan dengan rotografer gitu. Jadi saat kita menentukan packagingnya itu prosesnya mau seperti apa, rotographer atau flexo itu akan tergantung dari sisi volume dan ya biasanya kita akan lihat dulu volumenya kira-kira mau pakai yang rotographer atau pakai yang flexo. Mungkin bisa di-play videonya.
Hi, Steve Sickle with Consolidated Label here to explain flexographic printing. To start, flexographic presses are giant printing machines, superb at delivering high-end graphics printed
Dia
at rapid speed
speednya
and
tidak
low
secepat
cost.
tadi yang
Capable of completing
rotographer.
large orders very quickly, flexographic presses can print on almost any material, including paper, film, and metal foil. At Consolidated Label, we've expanded capabilities of our flexographic presses for more complicated processes such as cold foiling, embossing, and silk screening. Flexographic presses are web fed, meaning they are continuously fed material from large rolls of material stock, and allows us to print an average of 350 feet per minute. That's 4 miles of material an hour. Flexography or flexo is a form of printing process which utilizes a flexible release plate. Our plates are thin sheets of polymer material that is coated with a photosensitive surface. The relief image is a positive mirror, laser engraved printing plate digital artwork is wrapped around a print cylinder and installed into the press. The plate transfers the ink and prints onto the passing wet material. Each desired color within the label requires its own individual plate. And with 10 ink stations, we're capable of 10 colors in every flexo press run. What does 10 color capability mean? It's simple. Flexo can achieve virtually any color combination with the 4-color process of cyan, magenta, yellow, and black colored ink. So some artists may demand more than one shade of any given color, such as mixes of magenta being used for pink, maroon, and crimson on a single product. These desired variations require using matching paint film colors for a more accurate color match. We use a computerized ink matching system to create these paint film colors, which allow us to print multiple variations of any certain color. With 10 ink stations possible, that's 10 different colors. There's not much we can handle. At Consolidated Label, we use water-based ultraviolet curable inks, which do not dry in the air and create sharp colors using less ink. These differ from solvent inks, which are often found in personal inkjet printers and are harmful to the environment. After the UV ink is printed onto the material, the wet travels through a UV lamp, which cures the ink. In other words, it turns liquid ink into solid matter. These inks reduce our setup time and become press ready, lowering our production costs. After the labels have been printed, the last stop on the flexo press is the cutting die. A cutting die is a cylindrical blade that shapes labels by cutting off all the excess material. Each die is custom ordered to match label specifications made by the customer. At Consolidated Label, we utilize an entire fleet of flexographic presses to readily serve thousands of customers nationwide with high-quality product labels. I hope this video has been helpful in understanding flexographic printing. Should you be requiring labels for either long or short run, please contact our customer service department.
Jadi kalau misalnya di dunia printing untuk packaging itu ada dipecah menjadi ada namanya warna proses. Warna proses diingat-ingat terdiri dari cyan, yellow, magenta, black. Tadi dia sebutin kan. Jadi dari perpaduan warna tersebut bisa menjadi warna tertentu. Misalnya warna ungu gitu. Oh, warna ungu itu perpaduan antara misalnya cyan dan magenta. Kalau dicampurkan menjadi ungu. Atau menjadi warna hijau berarti misalnya cyan dan yellow dicampur menjadi warna green gitu. Jadi proses color itu tadi basic color itu yang tadi cyan, magenta, yellow, black. Nah tadi tipe-tipe inknya tadi lihat kan ada yang UV base, ada water base gitu kan. Kalau water base itu berarti dia base-nya water kemudian nanti didry secara pengeringan biasa. Tapi kalau UV dia berarti membutuhkan sinar UV supaya inknya itu bisa mengering. Nah kalau di company dimanapun bukan hanya di Nestle, proses packaging atau new product development stage-nya itu apa aja sih? Yang pertama itu ideation. Jadi misalnya tim marketing atau tim innovation punya idea untuk membuat produk baru. Mereka akan bikin tuh scratch-nya, kira-kira konsepnya itu seperti apa, kemudian financial analisisnya itu seperti apa. Jadi mereka membuat seperti proposal gitu. Kira-kira ini produknya mau seperti apa, temanya seperti apa, kemudian membawa revenue itu seperti apa. Jadi ada financial calculation dan lain-lain. Kemudian kalau itu sudah oke, diajukan ke manajemen. Kalau manajemennya oke, akan maju ke proses desain. Nah, desain di sini baru tim packaging akan mulai bekerja. Kira-kira oke, materialnya mau terbuat dari apa, kemudian technical feasibility-nya itu seperti apa. Dia mau misalnya dari tadi ya, yang balik lagi dari primary sampai ke tertiary packaging itu mau seperti apa. Kemudian product testing. Jadi nanti kita akan mempersiapkan mock-up-nya atau kayak produk pilotnya itu, kemudian akan dicoba oleh beberapa departemen. Kemudian kalau itu oke, baru kita akan ke next selanjutnya. Dan kalau desain oke, itu proses development. Development itu sudah menuju ke skala industri. Jadi kita akan melakukan namanya industrial trial gitu. Jadi belum menjadi produk yang sempurna, yang real seperti yang produk yang ada di depan kalian. Biasanya itu kita akan memprovide packaging itu masih dalam bentuk kosong atau blank packaging gitu ya. Nah, terus nanti kita akan melakukan line trial untuk memastikan bahwa packagingnya itu kompatibel dengan mesin. Gitu. Kemudian juga kita akan final artwork approval. Jadi untuk memastikan bahwa desain yang ada di packagingnya itu sudah benar gitu, berdasarkan dari sisi marketing, dari sisi technical maupun dari sistem regulasi gitu. Karena itu sangat bahaya sekali. Karena misalnya kayak komposisi, kemudian klaim-klaiman itu benar-benar harus di review, dan kita juga harus submit misalnya ke BPOM gitu ya. Jadi itu benar-benar critical di sini. Kemudian kalau ini sudah oke gitu ya, sudah di-approve, kita akan launching gitu. Nah, setelah launching, jadi sudah diproduksi dalam skala industri, kemudian didistribusikan ke market-marketnya sampai ke distribusikan ke market. Kemudian nanti dalam waktu 6 bulan sampai 1 tahun setelah launching, biasanya company itu akan mereview kira-kira performance produk tersebut di market itu seperti apa sih, kira-kira sukses nggak gitu. Kalau misalnya sukses, oke, mereka akan continue gitu. Tapi kalau misalnya ternyata tidak laku, misalnya kayaknya konsumer kurang tertarik atau daya mereka nggak begitu mau beli gitu ya, akhirnya kita akan biasanya di discontinue. Nah, biasanya gimana sih kita menentukan material packaging? Yang pertama, kita harus tahu dulu tipe produknya, apakah dia liquid, apakah dia misalnya gas, ataukah dia solid gitu ya. Yang kemudian production prosesnya, jadi mesin fillingnya itu seperti apa? Apakah dia secara vertikal, apakah dia horizontal, ataukah dia misalnya proses pemanasan, misalnya dia retort atau dia pasteurization gitu. Jadi saat menentukan itu, proses tersebut itu sangat penting. Yang ketiga itu barrier properties. Jadi kira-kira produk tersebut kita harus produk karakteristiknya itu seperti apa sih? Misalnya kopi. Kopi itu paling sensitif terhadap apa sih? Berarti kan dia biasanya sangat sensitif terhadap moisture gitu. Jadi kita harus protect dia terhadap moisture. Berarti packaging barrier-nya itu harus berapa sih? Biasanya ada parameter khusus, namanya MVTR atau moisture value, MVTR and OTR. Jadi itu barrier packaging tersebut terhadap moisture dan oksigen. Itu ada angkanya tertentu. Kemudian safety and compliance ini akan dijelaskan oleh Pak Batran. Sustainability itu juga akan nanti dijelaskan oleh Pak Batran. Kemudian costing. Jadi kalau kita mendevelop suatu produk itu harus balance. Gitu. Kalau misalnya produknya itu premium, oke, we don't need to care about the cost. Biasanya kalau misalnya kayak kosmetik yang harganya juta-jutaan, they really not care about the cost, gitu, karena they will get a lot of margin. Tapi kalau kayak produk kita yang mass production kayak food, misalnya kayak Nestle atau other company, because we have to compete to our competitor, biasanya costing itu sangat penting. Tapi bagusnya di Nestle itu tidak murahan gitu. Nestle itu sangat care terhadap consumernya, jadi sometimes mereka balance gitu. Oke, secara cost bisa affordable, tapi can deliver all of this. Kemudian yang terakhir itu material selection. Jadi situ sangat penting juga, kita mau apa, misalnya rigid tadi seperti tadi, apa kita mau rigid atau menggunakan material atau single material atau paper based dan lain-lain. Jadi ini adalah consideration saat kita menentukan material packaging. Nah, packaging dan shelf life. Shelf life itu apa sih tadi? Shelf life itu adalah durasi atau expiry date yang misalnya produknya 1 tahun, 2 tahun. Gimana sih biasanya kita menentukan shelf life tersebut? Yang pertama, begini, ada 4 hal yang mempengaruhi shelf life dari produk. Yang pertama itu adalah oksigen, yang kedua adalah moisture, yang ketiga adalah heat exposure atau panas, yang ketiga adalah light exposure, kemudian heat exposure. Gitu ya. Ini yang 4 faktor ini yang akan mempengaruhi makanan tersebut akan cepat expired atau basi. Nah, kalau di company gimana sih mereka mengakses shelf life? Pertama ada dua method. Yang pertama direct method, yang kedua indirect method. Kalau direct method mereka akan melakukan tes berdasarkan monitoring performance. Yang tadi saya bilang kita kan ada industrial trial ya. Jadi dari produk hasil trial tersebut mereka akan monitor di lab gitu. Dan dimonitor by month gitu. Nanti dicek apakah produknya ini masih bisa dimakan atau enggak, kadar moisture-nya berapa, kadar oksigennya berapa. Jadi ada parameter-parameter tersebut. Jadi ada juga dari sisi sensory gitu ya, misalkan oke dari sisi bau, dari sisi rasa gitu. Jadi ada parameter-parameter tertentu berdasarkan produk karakteristik gitu. Misalnya kalau kayak kopi itu kalau dari standarnya maksimum moisture content-nya itu 5%. Nah, jadi kita harus tahu nih, pokoknya dia berapa lama sih sampai dia mencapai moisture-nya itu 5%, apakah 1 tahun, 2 tahun gitu. Semakin lama kita bisa menahan dia sampai ke angka 5% tersebut, berarti dari packaging-nya itu lebih baik, makin baik gitu. Kemudian yang kedua itu indirect method. Indirect method itu seperti apa sih? Jadi kalau di Nestle itu kita punya software khusus, jadi mereka udah canggih lah gitu, kayak kita tinggal masukin packaging spesifikasinya, kemudian berapa kotak packaging, misalnya packagingnya seperti ini gitu. Berapa sih luas kontak area packaging tersebut yang kotak dengan produk, itu ada calculation-nya, ada rumusnya. Nanti kita masukin, kemudian kita masukin juga produk karakteristiknya seperti apa. Kemudian initial moisture, misalnya kopi bu, kita ada yang namanya initial moisture content. Jadi waktu coffee powder itu diproduksi, itu kadar moisture-nya itu berapa? Itu ada batasnya, maksimumnya berapa? Kemudian maksimumnya kan 5%. Jadi kita maksudnya oke, initialnya berapa, maksimumnya itu berapa. Nanti dia ada rumusnya tersendiri, dikalkulate kira-kira shelf life produk itu berapa. Oke, I think that's it. Enough from me. Saya mau bertanya, mungkin ada 2 pertanyaan lagi. Yang pertama, kira-kira siapa yang bisa menjelaskan tipe-tipe packaging berdasarkan struktur? Ayo. Tadi loh ada 3 loh. Ada yang mau jawab? Oke, Pak, silakan. It's fine. Tidak ada yang mau jawab.
Ada yang rigid, ada yang fleksibel, ada yang semi rigid.
Oke, thank you, Pak. Nah ini satu, ini hadiahnya cukup menarik. Pertanyaannya apa ya? Pertanyaannya tadi kalau misalnya ada yang bisa menyebutkan 2 teknologi printing di flexible packaging dan perbedaannya apa? Ada yang bisa jawab? Tadi itu loh ya, ada videonya tadi loh. Just try. Ada yang dari produk, ada yang dari video, sama satu lagi yang flexible packaging. Kalau transfer ini gimana? Yang saya lihat tuh perbedaannya tuh ada 4 juta bahkan ada Ada yang bisa jawab lebih bagus?
Ada, sorry.
Oke.
Tadi kalau nggak salah tuh antara flexograph sama fotograf. Kalau flexograph ini kan bisa produce dalam jumlah banyak. Jadi mungkin idealnya buat mass produce, tapi downside-nya itu tadi coloring sama volumenya tuh kan fotograf tuh yang kecil dan mass produce itu sih.
Kalau yang fotografer,
Fotograf tuh bisa produce colornya tuh bisa lebih lively gitu, lebih live tapi lebih hidup.
oke.
Tapi untuk volume mungkin lebih gede gitu.
Oke. Kalau transfer in-nya,
Trans.
yang bigger plate-nya kan ada 2 plate tuh. Yang
Oh.
satunya, kalau fotografer dari apa?
Itu box nggak sih kalau nggak salah? Yang sleeve exchange gitu,
Yang tadi udah dijelaskan.
layering gitu iya.
Di Grab,
Itu yang box bukan?
ya betul.
Oh,
Oke, kalau yang satunya,
wah itu yang salah ini.
it's right, it's right. Oke, ini kalau kamu. Oke, thank you semua. Terima kasih.
Oke, kasih banyak Ibu Stephanie atas materi fundamental packagingnya. Semoga apa yang saya sampaikan dapat menambah pengetahuan serta membuka perspektif baru bagi kita semua. Oke, teman-teman, karena kita masih ada waktu, izinkan saya mau memberikan beberapa pertanyaan kepada Ibu Stephanie dari beberapa peserta kami. Bentar. Jadi ada satu dari seorang Troy Andrew yang menanya, what is the most challenging packaging to produce?
Kalau bagi saya yang paling most challenging itu gini ya, karena saya punya 2 pengalaman. Yang pertama itu saya di personal care, yang kedua di foods. Kalau di personal care itu we really don't care about the product inside mostly. Karena biasanya produk yang di dalam itu lebih agresif dibandingkan packaging. So at that time we more protect the packaging instead of the product inside. Jadi jangan sampai produk yang di luarnya itu misalnya peel off atau apa, karena kalau personal care itu dia punya ada perfume. Biasanya perfume yang mengandung alkohol dia akan lebih agresif untuk meng-attack packaging. Tapi kalau foods it's the other around. Jadi packagingnya yang harus protect si produk inside tanpa ada manipulation. Nanti Pak Batran akan menjelaskan tersebut. Jadi agak struggling di awal saya waktu join Nestle karena way of working itu tuh kayak lebih berat dilihat. Jadi yang pertama apalagi Nestle mereka itu sangat concern terhadap safety. Jadi gimana sih menciptakan suatu balance packagingnya itu bisa memprotek di dalam produk yang di dalamnya. At the same time juga kita harus deliver sustainability karena Nestle itu sangat concern terhadap sustainability. Jadi packagingnya itu harus ramah lingkungan. Sedangkan kalau packaging ramah lingkungan biasanya barrier propertiesnya itu tidak sebaik kayak tadi yang saya bilang packaging barrier yang terbaik itu biasanya dari aluminium misalnya untuk flexible packaging. Kalau dia yang sustainability dia berarti base-nya itu harus pakai PP, nanti dijelasin juga. Sehingga barrier performance-nya itu tidak sebaik si aluminium. Nah jadi harus balance gitu antara cost kita juga nggak bisa kayak terlalu boros mengeluarkan cost di situ, tapi juga jadi affordable, tapi bisa memiliki packaging barrier yang bagus dan at the same time juga memiliki bisa compatible dengan musim. Jadi menemukan kesinambungan antara faktor-faktor tersebut itu nggak gampang gitu. Dan itu tidak ada acceleration test. Kalau di company yang lain biasanya bisa tuh, misalnya oke, shelf life-nya 2 tahun, di accelerate secara 3 bulan, misalnya 3 bulan dia bisa predict untuk 2 tahun. Kalau di Nestle itu nggak boleh. Di Nestle kalau 2 tahun ya harus 2 tahun. Jadi can you imagine gitu? Selama 2 tahun harus monitoring month by month, harus ngeliatin gitu secara safety and compliance, secara sustainability, dan secara cost. Gitu. So, ya challenge-nya itu tuh di situ sih.
Izin Bu, ini ada satu pertanyaan lagi. Sebentar. Ini ada yang nanya dari namanya Adlin. Ibu Yesi, bagaimana potensi packaging sustainable yang mudah terbiodegradasi, terutama yang dari bahan alam? Apakah sudah ada aplikasinya di industri?
Sorry about that. The question is about sustainability. So, is it fine if I keep it for you?
Oke, kalau gitu saya simpan dulu ya.
Also, sorry.
Untuk yang satu lagi yang ini dari Larasati Sekar Arum, dia bertanya, what do you do to defective packages and what are things to look at to label them as defective? Cara lihat packaging yang defective gimana dan cara label ya defective. Jadi yang bentuknya mungkin yang sesuai.
Ada, jadi kalau itu kan kita punya quality standard ya. Jadi kalau dari sisi packaging udah ada standar-standarnya, misalnya oke, secara visual berarti dia harus misalnya sesuai dengan technical drawingnya, dia tidak boleh miring, dia harus presisi. Kemudian misalnya dari sisi machinability yang tadi tidak boleh bocor, kemudian misalnya gampang dibuka, gampang disobek, kemudian secara convenience misalnya dia tidak boleh lecek, jadi banyak hal.
Oke, terima kasih Bu. Untuk para hadirin, maafkan karena kita keterbatasan waktu, maka sesi tanya jawabnya kita cukupkan sampai di sini dulu. Sekali lagi terima kasih Bu Stephanie atas jawaban-jawabannya yang Nah, selanjutnya kita akan mendengarkan materi kedua yang tidak kalah menarik dari Ibu Stephanie. Namun saya ingin menjelaskan lagi untuk para peserta yang ingin bertanya, nanti langsung aja tuliskan pertanyaannya melalui Google Form yang telah dibagikan oleh panitia. Oke, baik, dengan itu marilah kita sambut dengan hangat Mr. Muhammad Batra dari Nestle Menar yang akan menyampaikan langsung berikutnya.
So welcome everyone. As Yesi told me, I have to start with Salamat Bali. It's good morning, if I'm not mistaken. Pardon me for my voice, maybe it's not very clear. Do you hear me clearly at the end? Is it clear? Do you understand? Well? Good? Not good? Good. Amazing. Maybe the bad news, the 2 coming sessions will be completely in English because I don't speak Indonesian. But the good news, you will not have any exams about it, so it's fine. It's not a big deal. But I hope you will get what we will explain. First, I would like, of course, to thank the university, Ibu Judy and Pa Andy for the kind invitation. They invited me to come here. Thank you so much for the kind invitation. It's really a pleasure. And I would like to tell you guys that you are really lucky that the university brings the industries to your university and share what the industries do in the real market. I was a student. I didn't have this privilege in my university. So when I got the invitation, I was really pleased with the mindset of the administration and the university, of the professors, that they do give or invite the companies to the university to give you the real, I would say, hands-on experience from the market. Second thing, it's my first time in Indonesia, and I'm really impressed by Indonesia. I really liked it. You are very quiet, calm people, very decent. Like you make me feel embarrassed by your decency. So you are very decent, and thank you so much for this. Really impressive. Maybe before we start, a quick word about me. First of all, can we switch off this slide, or it's everything? This part? Or no? Because I believe you will not be able to see if this is okay. I believe this is okay. I hope you will not sleep if it's not lighting, but this is for you to be able to see. So my name is Mohammed Nasran. My education, I'm from Egypt. I'm coming from Nestle MENA. So in MENA, it's 19 countries in the Middle East, from Morocco, all the countries to Iran. So we have 19 countries in MENA, and I work for Nestle MENA. I'm Egyptian. By education, I am a pharmacist, so I got my... What? Okay. I got my bachelor's degree from the Faculty of Pharmacy. Then I got my master's in chemistry. Surprisingly enough, I don't really like chemistry, but I had to do pharmacy. And then, after I graduated from pharmacy, I found out that I'm not really interested in the pharmaceutical career. This is not a career for me. That's why I tell you, you are lucky, because you get people from market to tell you their experience about the real career. After I finished my studies, I found this pharmaceutical career is not for me. Then I wanted to shift to food, FMCGs. Then I thought, okay, how can I do this shift? I found a master's degree in food chemistry. So I went to this master's in food chemistry to be able to switch to food industry. So I got that master's degree in food chemistry. Then I switched it to Nestle, to food industries. When I started my career, I started as teaching assistant in the faculty of pharmacy. So I'm a little bit familiar with the academic career. I stayed like 5 years there. Then I started joining Nestle in 2014. I started as quality assurance in packaging, so I was doing some inspections for packaging. Then I shifted to food safety, so it's another section under quality. And at this time I was also handling quality pillar, which is something related to continuous improvement. I'm not sure if you are familiar with the terminology total performance management. It's all about continuous improvement to the processes we have. So I handling that part. Then I moved to production in infancy, so I shifted from quality to production. And I was also in the continuous improvement instead of the quality pillar. I was in the focused improvement pillar, which is interested in problem solving. So any problem solving technique is under this focused improvement pillar. Then later on, moved to application group, which is our R&D. In Nestle, we call it application group, like product development, for a couple of years as well. Then I went on a mission which is called Performance Acceleration. It's a team that goes to factories to do projects, concentrated projects, to help improve the performance of the factory. The project I had was in UK. I did only one project. Then I returned back to Egypt as a plant manager. So I was managing a factory for Maggi, if you know Maggi. Then I landed into packaging again in 2023 as MENA Packaging Compliance Manager. This is my journey through Nestle. Okay, back to our topic today, packaging sustainability. What we'll be talking about, three main sections. We'll be talking about the sustainability frameworks, the SDGs and ESG. Then we'll be talking about circular economy and sustainable packaging. And finally, we'll be talking about ecosystem for circularity and packaging sustainability. These are the main topics we'll be talking about. Maybe before we start getting into details, we'd like to know, what do we mean by sustainability? We hear the word like too much, sustainability. What does it mean for you? Anything? Any idea? No idea. Okay. Actually, what I would like to start with understanding sustainability, because before we get into packaging sustainability, it's better we have the big picture first. Then we know where packaging sustainability fits. Before we just jump into packaging sustainability, it's good we know the big picture. So let's say that started in 1987, there was a UN committee or meeting, and they issued a report called Our Common Future. And there, in that year, they defined sustainability as meeting the needs of the present without compromising the ability of future generations to meet their own needs. So basically, it's like, let's live in our present in a good way, but we also preserve the resources of the planet so that the next generations can also live in a good way. Then it didn't stay at on that definition. It kept developing till in 2015, they came, or the UN came, the United Nations came with what we call Sustainable Development Goals. So the whole world met in the UN, and they brainstormed, and they got 17 goals that if we meet these 17 goals, this was like the agenda or the target, we need by 2030, we meet these 17 goals, then we can make the world live in peace and in prosperity. The 17 goals are like diverse, they cover a lot of things. So you can have here, I don't know if you can read or not, no poverty, zero hunger, good health, I can't read, quality education, then gender equality. So they have like 17 different goals. If the countries of the world work towards these 17 goals, then the whole world will live in peace and prosperity. Good. Now this is coming from the UN. Why is this relevant to business? Now this is, okay, I'm a business owner. The UN do whatever they want. But why is this relevant to me as a business owner or as a company? Is it relevant or not relevant? Why? Can anyone expect anything? No? Okay. Why is it relevant? Because, of course, if we say the UN or the countries, now this is their direction. They are working towards preserving the planet resources. They are working towards having gender equality. They are working towards energy conservation or less water consumption. This is the direction of the whole world, the countries. We expect the countries then to put some regulations and restrictions for that. And of course, once they put these regulations, people have, or businesses have to adapt. And since they have to adapt, they have to rethink the way they do their business. Then, why it is relevant? Because for sure, new market opportunities will appear. Just for example, if we will be talking now, we need to make our packaging sustainable. Before, we didn't have to make it sustainable. To make it sustainable, we need to change the structure of our packaging. Then now, if I'm a packaging manufacturer and I do this change, I own the technology, of course, a new market opportunity will open for me. Because this is the trend now of the industry. The same for energy, clean energy. Instead of using the normal energy, how to make the energy renewable. I am using renewable energy. So if I am pioneering in this direction, it opens for me new business opportunity, new market. That's why it's relevant for the business to understand the direction of the world. Of course, having new market opportunities will the result of this is financial growth. Not only because it opens new business opportunities, but investors will put more money or invest more in companies that are sustainably conscious. If your corporate is sustainably conscious, it's more attractive to investors. They put more money in your company and it helps your business to grow. Then, of course, it enhances your brand reputation. So if I claim on my product that it's made of, for example, recycled material, like the packaging made of recycled material, or of less energy consumption, or any of the sustainability claims, this will enhance the reputation of my brand. And enhancing the reputation of my brand, this will also increase the loyalty of the consumers to my brand, so that people are more willing to pay even extra cost to buy my product. Why? Because they know my product preserves the resources of the planet. It's good for them, it's good for their kids, and for the generation to come. Also, being sustainably conscious improves the operation and risk management, because a lot of the sustainability initiatives are about reducing energy consumption. So if I reduce my energy consumption, I'm reducing my cost, I'm being more leaner. Why also it improves the risk management? Because as I said, we might expect all of a sudden to get a regulation that bans the usage of one material, and maybe my business depends on that material. If this happens, all of a sudden I'm in a big trouble. So being cautious about this, it improves also the risk management of my business. Finally, this attracts talents, because now people in new generations would like to work more in companies that work for a purpose, that they preserve the energy and the planet resources. Well, we know now that SDG, Sustainability Development Goals, is the direction of the UN. And the corporates and businesses need to follow this direction. It's important for them. Now, how can we measure, or how can corporates and businesses say to the investors or to the world if they are performing well or not performing well in applying or fulfilling these goals? The answer is ESG, not SDG. SDG is Sustainability Development Goals, but to operationalize or make it measurable, corporates follow ESG policies, which is environmental, social, and governance. So ESG is how the corporates translate their performance to achieve sustainability goals. They translate it into ESG. To give more idea by what this ESG means or tackles. So for environmental, for example, you would see companies talk about their greenhouse gas emissions, how much greenhouse gas they put into the market. Anyone is familiar with what is greenhouse gas? Whoever knows, just raise your hand. Only one. Good. Maybe you can tell us what is greenhouse gas, if you don't mind.
Good morning, everyone. Greenhouse gas is gas that affects the environment. Emission gas that affect the environment, for example, is CO2, and then CO, NOx, and the latter.
Amazing. Very perfect. These are some gases that when produced in the atmosphere, they absorb the heat and they keep it in the planet. That's why they contribute to the global warming, which is not good for the planet. I was not planning to give the gifts now, but you deserve a good gift now. Thank you so much. Amazing. Well done. So where are we now? We were saying, okay, I'm a business, I'm a corporate. I want to tell the world my initiatives or my performance towards achieving the SDGs. How we do it? We do it by the ESG. So in the environment, we can tell the world our measure in how much CO2 or greenhouse gases we emit. This is measurable. We can tell exactly. Like last year, we emitted 100 tons. We did some initiatives that now we emitted 90. So we are reducing. Then more initiatives, we are reducing. So this is a measurable thing that we can tell. Another thing is like our water consumption. Like our operations were consuming water by, 1,000 liters. But now we did efficiency projects, now we are reducing our water consumption. This is another measure. And instead of having just vague things or just broad goals, no, now we can have measurable things. Another thing also, energy consumption from renewable energy. I can tell the world that I was using my energy 100% non-renewable, but I did projects that now I use 90% or 80% renewable. This is also a measurable thing. Waste generation, again, how tons of waste I generated. Deforestation and air pollution, how many trees I cut and so on. These are all measurable things I can tell as my performance at the end. And all what we are talking about here, just to give also the big picture, are non-financial performance targets, because usually at the end of every year, to be attractive to investors, every company declare its own financial performance. They say this is our profit, so if you invest in us, like you buy, put $1 here, you will at the end get, $2. This is financial performance. But this is not financial performance. Also companies declare this, because as we said, now investors are willing to invest more in companies that contribute to the SDG. When it comes to social aspect of it, so it's like diversity and inclusion. Now companies can tell exactly how many males and females as a ratio, how many females at their senior level management. This is also another measure. human rights and labor standards, health and safety, community relation and volunteering. They can share their, we call creating a shared value, their contribution to the community in a measurable way so that the investors are aware how do they perform in these aspects. Governance is about the governance of the corporate or the business that mainly prevents corruption. So things that they can declare or measure, their reporting policy and internal control, how do they do their internal control, anti-corruption policies, what are their policies for anti-corruption. They can also declare their executive compensation versus employee compensation, like the CEO versus the average employee, like salary. Things like broad independence organization structure, like their board, like their top management are independent, not only influenced by other like parties or something like this. So the idea that we like, the message we need to have here, that the world or the UN is going or targeting sustainability development goals, 17 goals, they are broad. Then corporates and businesses, in order to achieve these goals, they follow ESG policies, which are things to be measured. This is, we will not go into details, but just an idea, gives an idea what companies report at the end of the year. The report measures something like this. Like very quickly, greenhouse gas, okay, how many tons? So in 2024, we emitted like 15, then we did 10% reduction. This is things they report at the end of the year as their performance. As we can see, if this is the 17 goals of SDG, we see that they are completely interlinked with the ESG. As we said, ESG is just the measure or the things you can measure with SDG. Where do you think packaging sustainability would fit here? In which side? If we talk about packaging sustainability, would it be under environmental, social, or governance? Mainly. Very difficult question. Not really difficult, it's very easy. Any guess? Just a guess.
Environmental.
Environmental, amazing, yes. Packaging sustainability would really fit under environmental, and we will see why in a minute. Just to give you an idea why packaging sustainability is important and why it's important for the environment. These are some numbers I tried to collect from different sources. It was interesting for me also to look at the numbers. For example, they tell you 30% of all waste in landfill is attributed to the packaging in the US. So 30% of the landfill is due to packaging. It's a big number, but this is in the US. Another figure was 1.3 billion tons are coming from food, and food packaging is a major contributor for them. Why food packaging can be a major contributor? Because as Yesi was saying, packaging plays a very important role in preserving the food. So if packaging is not performing its function well, I need to throw food, which generates waste. Okay? So imagine 1.3 billion tons, it's a huge amount. 8 million tons of plastic waste enter ocean each year. So imagine ocean will dump, we keep dumping 8 million tons in the oceans every year from plastics. We have 1.2 billion tons of carbon, of CO2 coming from packaging. It's also very huge impact in the environment. 10% of the global greenhouse gas emission globally is coming from packaging. And as we said, our target is to reduce greenhouse gas. And despite all of these, we have only 9% recycling. Imagine we don't recycle most of our packaging. most of our packaging is virgin, so we keep producing and dump to the environment. We produce, we dump to the environment. We keep dumping to the environment, we do not recycle. Then, okay, the question, we need to have our packaging what? Sustainable, to be environmentally friendly, to reduce the impact on the environment. That's why we'll be talking about the circular economy and packaging sustainability. So packaging or sustainable packaging would fit under the circular economy concept. The normal economy, or before, the economy was we call linear economy. It was following the take, like we get the resources from the planet, we make, we manufacture, we produce, and then we use and we dispose. And this is the harmful way to the environment. This is what we need to avoid. We need to shift from the linear economy into the circular economy. We keep the packaging in the economy as long as possible. We keep using the packaging in the market as long as possible. This is where we need to move. So we start with we produce, we use, then we collect the packaging, we don't dispose it, then we recycle it. We need to shift towards this mindset so that we reduce the impact of the packaging on the environment. How we can make our packaging sustainable and fit into this circular economy? Anything that can reduce the environmental impact of the packaging on the packaging makes it sustainable. Here are some of the strategies that we will be talking about. First one is packaging optimization, then using renewable materials, biodegradable materials, recycled materials, reuse and refill, and then design for recycling. Just would like to know, am I going so fast or is it okay? Okay, good. Yes. Okay, packaging optimization. We said that we dump to the environment a lot of packaging. So the first strategy would be, don't use packaging, don't use unnecessary packaging. So reduce its usage from the beginning, design it in a way to use less. This is what we mean by packaging optimization. To give some examples, water bottles used to have this sleeve around. The only function of that sleeve was to make the consumer feel like protected, that this is new bottle, it was not used before or like opened, filled by, I don't know, any source of water, and it's unsafe. This was the only use of that sleeve. But this is now considered over packaging. Then the solution was to change the design of the cap. When you open it, you have this click. Once you have this click, you know that it was not open before, it is new, and then you completely remove this outer sleeve. So this is less packaging because it's unnecessary packaging. Similarly, head space reduction. So the space from the end here to the top is called head space. Sometimes some businesses like to have big head space to give the impact to the consumer, like we sell you big size with this lower cost. In reality, the quantity is the same, but they just increase the packaging. But this is again, it's over packaging, it's not needed. So instead of having high space, high head space, reduce the head space because all of this space you don't need. It's just over packaging. More carbon dioxide, more energy. It's not good. So reduce it. Again, number of layers. Instead of having a carton with 5 layers, for example, and I only need 3, why do I need to over-specify my carton? Use 3 layers only. Don't use 5 layers. 3 layers make them 2. Use whatever you really need. And finally, what we call light weighting or down gauging. For water bottles, for example, we reduced the thickness because the thicker bottles wouldn't add any benefit to the consumers, wouldn't add any benefit to the companies, but you reduce the weight, then you reduce the packaging quantity you put into the market. This is one strategy of how you reduce the impact of packaging on environment. The second strategy is renewable materials. For example, renewable materials, of course, to use your starting substances that come from renewable source, not from the fossil fuel that we know about, but from renewable sources. So, for example, instead of using plastic packaging, I move to paper, because plastic comes from the soil, comes from petroleum, then they do extraction, then they get to the polymers, which is not renewable source. Okay, I can, instead of using plastic bag, I can shift to paper packaging. So it comes from renewable sources. This is better for the environment. Why is better? Because I can regenerate what? The trees afterwards. Also from plastic packaging, the normal plastic packaging, I can use bioplastic. What do you mean by bioplastics? Any idea? Bio. Since we inserted the word bio, what would it mean? Seems like you had it before. Please. Degrade easier. Actually, it degrades easier, but it's not necessarily bio. So, I mean, this is not the definition of bio. Like, bioplastics, yes, degrades easier, but it's not the only thing that degrades easier, because we will come to biodegradable. Okay? So, you are close, but not really. Yes, please.
Bioplastics is made out of biomass.
Biomass.
Yes.
Yes.
Which can.
I hope you are not using ChatGPT to answer. I will do it as a student, but don't do it.
Yes, it's using renewable materials such as plants, like seaweed as well. Such as seaweed as well, or they're using biomass that has been already processed. Like for an example, coconut shells that have been used to extract oil and things like that.
Amazing, perfect. Yes, so it is a plastic coming from a biological source, natural source, either from the plant source, or from bacteria. We have what we call polylactic acid, so it's a kind of polymer, and we have what we call polylactic acid bacteria. So this bacteria, when it generates polylactic acid as a waste. So we can use this polylactic acid in industry. I believe you deserve also one gift. I don't know what to have you. Maybe I will not have more gifts at the end, I'm sorry. Thank you.
Thank you.
So this is another strategy as well. The third strategy is to have biodegradable materials. So biodegradable materials that are the materials that biodegrade in the environment easily. So instead of using a material that does not degrade in the environment naturally, I move to material that degrades in the environment naturally. Like we have this maybe bioplastics, we have paper, it also degrades naturally. So when we dispose it in the landfill, it will degrade. It will not stay in the environment forever. It will naturally degrade. This is good for the environment as well. Then, using recycled material. And here we will stay a little bit or spend some time here. So instead of using virgin plastic, use recycled plastic. Instead of using virgin paper, use recycled paper. As we said, in the circular economy, our objective is to keep the material in the market or in the value chain as long as possible. So when I start with virgin plastic, so initially I start with virgin, but when I keep recycling it, I don't put it as a waste. No, I keep its recycling, so I preserve its value in the market longer time. The common schemes of recycling plastics that we have so far, I don't know if it's clear or not. I hope it's clearish, no? Okay. So the process of producing the virgin plastic first, it comes from oil. They do extraction, so they have some oil fractions. Then they get the monomers. So the monomers are the building blocks of the polymers. These polymers are the starting materials of the plastics. So we have the plastic products. Then consumers waste their plastics. If we stop here, this is the end of the linear economy that we're talking about. So imagine that if we follow the linear economy, we'll keep from the oil till waste, oil, waste, oil, waste, harmful to the environment. Now, the direction is to recycle. To recycle, we have the recycling facilities that do the sorting, so they collect this waste. So they just get our garbage. It's very huge, facility. They get tons of the waste, and here they do sorting. Why do they do sorting? Because each material has its own sorting stream. I cannot, for example, recycle packaging, plastics, the same way I would recycle metal. Metal has its own stream, plastic has its own stream. That's why we need to do sorting. Then we get the plastic waste. So the function of this facility is to do the sorting into PET bottles, polypropylene, metals, glass, and so on. Here we are focusing about the PET plastic recycling. There are two kinds of recycling: chemical recycling and mechanical recycling and chemical recycling. When we do mechanical recycling, it's actually we keep the material into its polymeric form. We do not break down the polymer into monomers. However, when we talk about chemical recycling, we do depolymerization into monomers, then we repolymerize into the polymers. This is the major difference actually between them. So keep in mind that what are monomers? Are the building blocks of polymers. You know what polymers are, huh? I believe you are familiar with polymers, correct? Very good. So in mechanical, it's mechanical, it's just the mechanical forces. It does not break down the polymers into monomers, keeps it in its polymeric phase. Then they use this polymer again to convert it into the plastic products. But in chemical recycling, they apply some chemical reactions to break down the polymer into monomers. Okay. With this distinction, we need to see a bit of a comparison between them. So mechanical is physical process, so we sort, clean, and so on. Then we reprocess into pellets that are then used into the bottles. Then in the chemical, PET is broken down in its original chemical monomers. So when you break into the original monomers, it is like you have a virgin quality PET. Because the challenge of recycling in food industry is what? Two things. Now I need to recycle, imagine, I'm getting plastic from the waste, from the garbage. I want to recycle it to make food or water bottles to drink. So I need to tell my consumer that this bottle, imagine this bottle, I tell you it is coming from the garbage. How willing you would be to drink this water? Who would drink if I tell you this bottle is coming from garbage? Not willing, correct? Why? You would think, first of all, it's unsafe. It's full of bacteria, full of chemicals. It's unsafe. Maybe I don't feel calm. Yeah? So the challenge in general in the recycling technologies is first for food, I'm talking now about food, is to make it safe. So I need to have either decontamination steps, like the waste I'm coming or I'm collecting, I remove the contaminants for it. So I have decontamination, which is what the physical process does, or the mechanical recycling does. They wash, we will see the process, to have decontamination. But decontamination, can you expect anything in the world to be 100% efficient? Any process to be 100%? Would never be. So we cannot remove 100% of the contaminants. It would still be efficient to remove the contaminants to be safe, like the level we have, if we have, would still be safe, but we still have some contaminants. But versus the chemical recycling, you now convert the plastic into the starting monomers. You can get completely rid of all your contaminants, and you rebuild the monomers again into the polymer. That's why we call it virgin quality, because you are no longer using the same polymer that has the contaminants around. No, you broke it down to the monomers, no contaminants, then you repolymerize, which is as if it is virgin. It is recycled, but the quality is virgin. So this is the advantage of the chemical recycling. Enables circularity of hard to recycle plastics. This is what I was saying, it is more efficient when it comes to decontamination. On the contrary, the mechanical recycling is cost effective compared to chemical, is cheaper, and a low carbon footprint if we compare to the virgin, and we have well-established technologies. The disadvantages, mechanical process, because it is mechanical, it downgrades the quality of the polymer or the resin. You cannot keep recycling the material mechanically forever, because the quality over time degrades. And also, they cannot manage, or the decontamination cannot manage the highly colored materials, cannot get rid of them completely. This is why it downgrades the material. Versus the disadvantage of the chemical, it's high cost and it consumes a lot of energy. Why the mechanical recycling downgrades the quality of the resin? Maybe we need to look first on how mechanical recycling happens. I'm not sure if it's clear. Can you see well in the background? In the end, you can see well? Not really? No. Okay. I'll try to explain. So here we start with collecting the plastic bottles. Then we collect it into bales. So we have the PET bottles into big chunks, we call them bales. So in the recycling facility, so we have recycling PET, we do de-baling, so they separate the bottles from each other. Then we go to first step of the decontamination. As we said in the mechanical recycling, our target is to decontaminate as much as possible. So here, first step is metal separation. So any metal contamination in the bottles, bale, like with the waste, coming with the waste, will be separated here. Then the second step is label separation, because you have the label outside the bottle is not plastic, is not PET, so it would, if it goes to the stream, it would contaminate the stream. So we have what we call e-labeler. It removes the label from the bottle. Then it goes to the first step of washing. They wash the bottles by some chemicals and waters. Then they do shredding. They shred the bottles into pieces. Then they have floating separation. So it's like a sink full of water, and they dump the shredded bottles here. Then by the difference in density between the different plastics, you would have the PET goes down, and any polypropylene or polyethylene that is contaminating the stream would float on top. So we get rid of the top layer because this is not PET, and they get only the bottom layer to continue the recycling process. Then they go to another washing, which is hot wash. So again, they are like cleaning the material. They keep cleaning the material. Then drying, and after the drying, the output of this process is the PET flakes. Sometimes they sell this as a product on its own, but what really continues the process that they do extrusion, like similar to the extrusion Yessi was explaining. So it goes through this screw with heat to melt the flakes. So they melt here. Then they go to what is called solid state polymerization reactor. So it is a reactor that applies high heat under vacuum. Of course, here in this washing, you mechanically remove the non-volatile substances. Your contaminants, or the contaminants, I don't know if I'm going into much details, but your contaminants are classified into volatile and non-volatile. In all of these steps, the main target is the non-volatile. You can easily remove by the washing. And of course, you remove some of the volatile. But here, because you apply high heat and vacuum, like you are sucking, you remove also the volatile substances which are more dangerous actually, because they tend to migrate to food. So here is another decontamination step. So the vacuum removes the volatiles, and it's a polymerization reactor, so it preserves the polymer quality of the resin. Then you get the pellets. Here is a picture that was supposed to show you the different color of different recycled content. If you see, the more you increase the recycled content, the more darker the bottle will be. Why? Because there are things you cannot avoid. With waste, you would have mixed with inks, adhesives, all of these things, you cannot, with all the washing we have been saying, some of them would still remain in the stream. They will get out with the pellets. And also the high heat that we apply in the process changes the color. It actually makes a bit of oxidation of the resin, which changes the color of the resin itself. That's why the pellets become darker. And if you see the version like zero recycled is like clear, and as you keep increasing the recycled content, it becomes dark. Going to the first question, or maybe let's ask the question again. Following all of these steps, we can conclude that the recycled PET is safe or not safe. Washing, solid state polymerization. Is it safe or not safe? What? You are hesitant.
It's not safe.
Say the answer.
It's not safe.
Huh?
It's not safe.
Not safe. Okay, why?
Because there are contaminants that cannot be cleaned in any way.
Okay. so the concept for anything to be harmful, it has to reach a threshold that after or concentration, beyond it, it starts to have its harmful effect. Just to give a tangible idea, do you believe you have bacteria on your hand or not?
Yes.
Is it harmful?
No.
But if you have it more than usual, it will start to cause problems.
Yes.
Correct?
Correct.
Another example, if you take vitamin, is it good or bad?
Good.
Vitamins.
Depends.
Huh?
Depends on the use.
Good. But if you take lots of vitamin, you can get toxicity.
Yes.
Correct? So to say it is harmful or not, there must be certain concentration. If you exceed that concentration, it's harmful. So if we still have some contaminants here, doesn't necessarily mean it is harmful. The question would be, is it below that limit, or it's not below that limit, or above? So I would tell you it is below that limit. So is PET coming from mechanical recycling safe or unsafe?
Safe.
Safe. But the problem would be, would you like to buy a bottle that it looks grayish and it's written recycled? Even if you know it's safe, you would feel, I'm not willing to buy it. I'm not willing to buy it. So this is one challenge that faces the industry of recycling PET with mechanical recycling. Then, if you see the last one, it looks a little bit bluish. So the ad, it's 100% recycled, but I would like to remove this bad impression for the consumers. They add toners, they add colorant, they add this bluish color to the bottle so that the consumers, when they know that this is a recycled bottle, they don't feel it's unsafe. So it's masking their visual rejection to the bottle. Okay. Any questions so far? Is it clear? Good. Then to continue the strategies to make the packaging recyclable or sustainable, to reduce its environmental impact, is to have reuse and refill packaging. I actually copied this from Arthur McCarthy organization. It has or it divides the reuse and refill packaging according to whether it is refill or return, and edit at home or on the go. Let's see the models, it will be clear. So first thing is refill at home. So here the consumer buys the packaging, buys the bottle, then they consume the product, then they give you the refill, they come to you, give you the refill at home, and you refill it like this, and the cycle keeps going. So you buy it once, you buy the packaging once, then they come to you, give you the refill at home. Why this is good for the environment? What is the other alternative? That every time you would buy what? This bottle. Every time you would buy this bottle. Now you buy the bottle only once, they give you the refill at your home. So you use the one bottle, for a long time. This is what we were calling the circular economy. So it is less packaging consumption. The other model is refill on the go. So again, you buy the bottle, you consume it. Instead of they give you the refill, you go to a store or actually like a vending machine, you refill your bottle, then you go. So it's similar concept. Instead of they come to you to refill, you go to them to refill. But again, you buy the bottle only once. It's less packaging, less environmental impact. Then return on the go. you start by buying the product, then you return it. So they have collection stations where you return your bottle here, they take it, refill it, then you buy it again. So again, yes, every time you would buy the bottle, but the same bottle is reused. You do not buy new bottle, or they do not manufacture new bottle every single time. Because this bottle, you return to the manufacturer. You don't waste it. The key point here that you put in their collection, because they have their own collection like bins, so you return to their collection bins, then the manufacturer will take it from here to the facility, they reproduce it, then you rebuy it. Again, good for the environment. The last model would be return from home. So you buy, then you get the bottle here, you use it, you use, then here the business or the manufacturer comes, takes the empty bottle, gives you a new bottle, then they refill the empty bottle, then the cycle comes. This is following, I don't know about here, but in Egypt, following our Nestle Waters like model. We have 20 plus gallon, it's like very big. So we buy this gallon, they come to us, we buy it once, then we use it at home, then they come again, they give us a new bottle of water filled, and they take the empty one, in the facility, they clean it, then refill it, then the cycle continues. The point here is to use less packaging. Once you produce the packaging, you keep using it as much as possible. Finally, we'll talk about design for recycling. Okay, so let's say we cannot use less packaging, or even if we use less packaging, we cannot make it renewable or biodegradable. We have to be from like oil. At least design it to facilitate its recycling. By this, what do we mean? As Yesi was explaining, for flexible, just an example from flexible laminates, we used to have layers like this. So mainly it is PET, aluminium PE. And we said, okay, PET because it's easy to print on it. So it's easy for the communication and so on. Aluminium because of the barrier properties. We need to increase the shelf life of the food. Then PE is to have sealing to contain the food. Good. But this is not sustainable, or this is not designed for recycling. Why? We'll see, but the objective is to move from composite structure. What do you mean by composite? If you look at here, this PET, aluminium PE, so we have plastic, PET, and PE, polyethylene, are plastics. Then you have aluminium, okay? So it is a mix of plastics and aluminium. This is a composite, it's not one material. But versus, if we look here, if we have polypropylene, polyethylene, this we call monostructure. It is all of plastic. So why composite structures is not good, is not designed for recycling, and why monoplastics or monostructure is designed for recycling. We just said in the beginning, we do have the waste collection. Then we do what? Separation. So for the waste collecting facility, they have all kinds of waste together. Because imagine what you get out of your home. You don't separate in your home plastics, metals, glass. You would need to have a lot of space in your home to separate. So in our homes, we don't do this separation. So we put everything together. Put plastics with metals, glass, cartons, we put everything, food, put everything. So the facilities have everything together. Then they need to separate into plastic, like rigid plastic, flexible plastic, carton board, paper, glass, metals. Why? Because each one of these has a different recycling stream. The recycling process here is different than the recycling process here, and here, and here, and here, and here. Good. So, in order to be able to recycle, we need first to what? To what? Separate. If I cannot separate, I cannot recycle. Correct? So, going back to this structure, if you remember from the slide of EC, in between this layer, what do you have? To attach these layers together, what do you have? Huh? Are they, you get the three materials, you put them and it's one layer and that's it? You need to apply something to glue them together. So apply an adhesive, correct? So do you imagine you can easily separate these layers? It's not easy, cannot be separated, correct? But the recycling stream for the plastic is different than the metal. So this material is not designed for recycling because you cannot separate it. If you can separate it, it can be easy, but you cannot separate because of the adhesive. That's why moving to this monolayer, it's only plastic. You can easily recycle later on because you don't need separation. Actually, you can easily separate versus the carton and so on. That's why we say this structure of, for example, PET, aluminum PE, composite structure, these materials with different recycling streams, and it's difficult to separate. That's why they are not suitable for the recycling facilities, and they are non-recyclable. You cannot recycle this structure. But if you compare to that one, it's monostructure, materials with the same recycling stream, they will go to the same process, no problem. Then no need actually to separate. Anyway, they go to the same process. Then they are suitable for recycling facilities. So our objectives is to move from here, PET aluminum PE, to OPP, OPP, PE. It's good because we can do it, but also it comes with challenges. So what kind of challenges we have? When we were talking about aluminium, what was the function of aluminium, if you remember? Huh? What was the function of aluminium in the structure? Okay, you heard the word barrier. It was barrier. It was adding barrier. Okay.
So the function of aluminium is to protect the product from sunlight and to make the product more rigid.
Amazing. Correct. Oh, correct. Thank you so much. So yeah, it is barrier to protect the product. Okay, so it's a barrier to something. It's a barrier to what? What actually I need to prevent to get to the product? Sunlight, yes, and what else? Oxygen and water vapor, moisture. Okay. The barrier, now I need to remove aluminium, and instead of aluminium I have OPP, it's plastic. Plastic by design is more porous, has more holes in its structure. If you look on the plastic under the microscope, it will have pores, okay? Which means, is it better barrier than aluminium, or it's worse? It's worse. Aluminium will block anything, will not allow anything to go through it. Will block any oxygen, will block any water vapor to go through it. But OPP will allow some oxygen, allow some water vapor to go through. Which means, in order to be sustainable, which we need to move, but what will happen to the shelf life of the product? It will become less. So this is also one of the challenges that we need to address. Yeah, we need to work on the sustainability aspect. but also need to keep the shelf life of the product. So the direction now is to use what we call metallized OPP. Instead of using polypropylene film alone, we spray, we don't use an aluminum layer, it's not like this. We spray aluminum on it to make it metallized, so we add more structure to it to become more barrier. So in terms of the barrier properties, aluminum is better than the metallized OPP, and of course this is better than the non-metallized OPP. So shelf life and barrier properties is one of the challenges that we have with the design for recycling product or packaging, and we used it for some of our products. We could not maintain the same shelf life. We had to reduce the shelf life with the sustainable design for recycling packaging. Okay, second challenge. We said we can have here, or we move from PET aluminum to OPP. Okay. This is challenging for the printing. Why? First, when we print on the pack, you read the production date, the expiry date, correct? This is printed by the manufacturer. To print, you can use several technologies. One of them is inkjet, so it is ink. One of them is laser. So for the inkjet, it's like you have the ink and you spray it, okay? You have ink, it's chemical, liquid. You have a nozzle that sprays the ink onto the packaging. In order to have good ink or good printing, you need to ensure good adhesion. That when I spray that ink and it dries, I don't rub it and it goes away. So the adhesion is very important. And the adhesion depends on the interaction between the ink and the external layer. Because imagine here, you are spraying ink. So the ink interacts with which layer? External. PET or OPP. PET has higher surface tension, which means has better ability to have adhesion to the ink. While OPP has lower ability to have adhesion to the ink, which is again a challenge, because if I'm using in my facility inkjet, I'm printing the production date, expiry date, and so on, and it can be wiped out on the shelf, like if I'm moving or something like this, the consumers later on cannot read it. So this is a challenge that we face here. There are some solutions for this, to apply only on the printing area some varnish, chemically like modified material, to increase the adhesion on the printing area, or not use inkjet and you change your inking or printing system. But if I'm changing my ink system to laser, there is another challenge, because laser printing or laser coding works with a different concept. We said inkjet, you have the ink and you spray it. Laser is not like this. You have the laser burns the external layer and it stops at the inner layer. So if I'm in here in that model, it burns the PET, it just removes it and stops at the aluminum. So how do you see? Actually, when you have laser coding, anything that you can see means part of the PET layer was what? Removed. This is how you see it. When we move to the design for recycling material, when you have here OPP or metallized OPP and so on, with laser coding it actually does not stop on the first layer. It also removes some of the second layer, which is, in our case, if it's metallized OPP, it will be our barrier layer to improve what? The shelf life. Now I am making some holes as I'm printing, so I'm adding more holes, which means I'm even worsening the barrier properties, and I'm even further reducing what? The shelf life. So this is another challenge with the printing. Again, laser is, there are like 4 different technologies of laser. There are mild, there are strong, so the recommendation is to use the milder one and to print not on the body of the material, but on the seal. If I have a pack, but maybe we show it later. You need to see. There are solutions to this, but I mean, these are challenges. It doesn't mean that we are helpless, but there are solutions to this, and it keeps evolving. Then finally, the sealing window. Okay, we need to ensure good sealing. How actually the sealing happens? It happens that you have your material goes like this, and there are heated jaws. Going like this, pressure, they are heated. So, and they apply both heat and pressure. It's not pressure alone, not heat alone. Why we need to have both? Because you apply heat to melt the inner layer. You need the the PE layer, the inner layer, to be molten first. Once it is melted and you apply the pressure, now you can do the sealing. If it doesn't melt well, you will not be able to seal well, so you will have leakages. Okay, so we need heat, but also, if you heat too much, you will burn the external layer. Like you will buy the material and you will find a defect. It's as if you are ironing your clothes, you heat the iron too much, what will happen to the clothes? It will burn. The same for the packaging. If the heat is too much, it will burn, so it will shrink. It will make a visual defect. Why this structure was good? Because the melting point of the PET and the PE, the difference was huge. So it allows you to apply bigger heat here to be able to melt PE before PET starts to burn. But if you move to OPP and PE, the difference in the melting point is actually small. You do not have a high window to play. You need to be very accurate in your process parameters so that you apply enough heat to melt this one and also not to burn the OPP, because the difference is not big. So this is another challenge. Of course, the technology evolved, the design of the heaters and the jaws, like it's, I mean, we have research centers work only on this. It's a big thing. But there are solutions. But it's a challenge, but there are solutions. I believe that's it for the, like, how we can make the packaging sustainable, how we can reduce the impact of packaging environment. Then very quick word about the ecosystem of this circularity. I just would like to talk about what we call extended producer responsibility. As we started that the UN, the countries of the world, met together and defined their sustainability development goals. And we said, why is this relevant for business? Because if this is the direction of the government, of the authority, we expect there will be some regulations to enforce achieving these goals. EPR is one of the examples of this influence or of this direction. So extended producer responsibility is a policy that holds the producer financially and or physically responsible for the products of the entire life. What does it mean? Now I'm a brand owner, I'm Nestle. I'm producing, I believe this is not Nestle, but this is not Nestle, but okay. Whoever produces this bottle, you put this bottle in the market, you are responsible on this bottle till the end of life of this bottle. You don't just produce and then us as a government, we need to take care of its collection, recycling, waste management. No, the direction is no longer like this. The direction is whoever produces the bottle is responsible for the end life of that bottle. And why? Or how? Because there will be law. It becomes a law. It's not a joke. It's a law that now the producer will can meet certain recycling targets or pay fees. So if you don't meet these recycling targets, you will pay fees to the government. So that if you pay the fees, the government will take this money, and invest in the waste management, recycling scheme, and so on. So it's either you do it, or you pay fees so that the government will do it. So anyways, you are responsible. So the objective is to incentivize the companies to design the packaging to be more environmentally friendly, or they finance, they give the money needed for collection, sorting, treatment of the waste. So now it is the responsibility of the producers to take care of the end life of their product. Examples just to give you an idea of what we mean by certain recycling targets. Just for, I believe I have it. I have it. So, for example, you will pay more fees if you use higher weight than lower weight. So now the fees will be on the bottle weight. For example, above 2 grams, I'm just giving a number, you will pay fee. If your bottle is below 2 grams, you will not pay a fee. So the more weight of your product, the higher the fee you will pay. Another example, if you use renewable material, you will not pay fees, but if you do not use renewable material, you pay fees. So if you are renewable, no fees. Non-renewable, you pay fees. If you use recycled content, whether it's 10%, 30, whatever, they have the target, you pay no fees or low fees. If you use virgin, you pay higher fees. If your material is recyclable, designed to be recycled, you will pay lower fees. So all the strategies we were discussing, why companies are doing this? Because EPR is coming. If they do not convert their business models or their packaging to meet, this is not all, this is just example, this is not all. If they do not meet these things, they will pay fees at the end, which is extra cost, because they will not be cost efficient. They lose their customers. So they go down in a vicious cycle. One important thing we would like to end with is the recycling. There are two different kinds of recycling. What we call PIR, post-industrial recycling, and what we call PCR, post-consumer recycling. So from the definition, from what we see, post-consumer, where the material is recovered from the product after the consumer uses them. So they manufacture, put it on the shelf, consumer buys, consume, waste. We take this material after it's wasted and we recycle it. This is the post-consumer recycling. While post-industrial recycling, it doesn't go to the market, it is in the facility. So it is in the manufacturing process before it reaches the consumer. I don't know if you noticed or not in the video that was shown by Yesi for the bottles. They have these ejectors to remove the extra plastic. So you have the mold, then you have extra plastic, you have an ejector to remove the extra plastic. And they told in the video that this plastic is recycled. This is what kind of recycling? The extra plastic during the manufacturing process? Which kind? Oh my God. Huh? Okay. So post-consumer, it means that the product went to the consumer consumed it, and wasted it. Post-industrial, it is from the industrial process before it goes to the consumer. So the example that was in the video, while they are producing the empty bottles, empty, they come out with a mold, they shape it, then there are extra packaging. They kick out this extra packaging and reuse it. Which model of recycling is that? Post-consumer or post-industrial? Post-industrial, very good. What do you think is better for, or from the perspective of EPR, extended producer responsibility? We said that the governments would give incentive, like encourage you to be more sustainable. How do they encourage you? They ask you to pay higher fees if you are not sustainable, or lower fees if you are sustainable. Which model of this goes well or goes better with the EPR policy? The post-consumer or the post-industry? We set the objective of the EPR that the producer takes full responsibility for the product till its end life. This is the whole objective of EPR, that the producer gets the responsibility of the product till end life. Which fits that objective better? Post-consumer or post-industrial? Post-consumer, correct. Because this actually closes the loop. It is manufactured, goes to the consumer, goes to the waste, then we take it from waste and we recycle it. So the loop is closed, and again, the producer takes responsibility of the packaging they put in the market till the end of its life. They take it from waste. That's why usually when we say recycling, just to go back here, recycled will have low fees. We are not talking about post-industrial, because this is by design, you should have it. We are talking about post-consumer recycling would be having low fees in the EPR. I believe that was the last thing. Maybe the takeaway messages. Quickly recap. SDGs, Sustainability Development Goals. There are 17 global goals defined by to achieve peace and prosperity now and in the future. ESG is the way corporate and businesses operationalize and measure their SDGs contribution. Sustainable packaging falls under the environmental part of ESG. The ways to make packaging sustainable: packaging optimization, use renewable materials, use biodegradable materials, recycled materials, reuse and refill, design for recycling, and finally, EPR policies aims to incentivize the producers to take care of the product at the end of life. That's it. I don't know if you have any question, please feel free to ask. Thank you.
Thank you, Pak Batra, for your presentation about sustainable products. Would you mind taking a seat? You seem to be tired. I would also like to call the translator to help me with some of the questions here. Yeah, we have a couple of questions from our participants over here, if you wouldn't mind answering some of them. So one of the questions are, using recycled packaging poses a challenge to branding. Sure, it would attract more customers because it's more environmentally friendly, but it can be a double-edged sword because the question remains, is it safe or not? How would a brand keep its balance between masking and building the positive side of a brand and encouraging recycled packaging? Even though it is safe, but once customer realizes brand is masking the downside, it can be a bad influence to overall brand image.
I want to make sure I understand the question. So, whoever I will ask, I will tell you what I understand. If it's correct, please let me know it's correct. So the question is, using recycled packaging is good from the sustainability claim, but it's also not good because the consumers will think it is not safe. This is what the question means. Did I get the question right? Whoever asked the question? So Patrick, did I understand your question correct? Seems Patrick left. Okay.
Sorry, I just came back from the toilet.
No, it's fine. So I just want to understand, to make sure I understand the question correct. So you basically say that using recycled packaging is good for the sustainability aspect,
Yes.
but the consumers may link it that it is unsafe. That's why it can make the consumers not like the product and reduces its ability, willingness to buy.
Yes, correct.
Very good. This is perfectly correct. Then what do we do as business, and I wouldn't see as companies? Before we introduce or something like this introduced in the market, there has to be educational campaigns. So the industries together, like I would say Nestle, Coca-Cola, PepsiCo, all of the big players, they go with campaigns on the TV, on the media, to educate the consumers. You cannot move or make a big change without educating the consumers first, or as you correctly mentioned, you will lose them. So to move to recycling materials like this, some campaigns in the media are ongoing. The same, for example, when I was talking about the removing of the plastic sleeve, because it's not about recycling now. You just remove the plastic sleeve on the cap. Then the consumer automatically will think this is used before because I can see the sleeve. You cannot move or have this shift without educating the consumers first. So there was campaigns on the TV, on the media, to tell the consumers that this is what you will get, but it's safe, and how you ensure the safety? By having this clip. The same for recycled materials. I'm not sure about here, but I think it's the way, because it's the way everywhere. There is consumer campaigns by all the industry players to educate the consumer. You will find it recycled, but it is safe, and it's approved by the Ministry of Health, for example. It's approved by FDA, for example. It's approved by EFSA. EFSA is the European Food Safety Authority. So without having these educational campaigns, you would lose the consumer, yes? But how we do it? We do the educational campaigns. Thank you.
Thank you.
We have one more question that we can try to ask.
We have a question from Titus. His question is, in your opinion, Mr. Bakan, how can we educate people to use products with recycled packaging?
I believe it's the same answer. The companies, the players, have to do this educational campaigns. You need to educate the consumers. So it's not one company work, cannot be. It's even unfair, because if it's one company doing it, all the other companies will benefit. So it is usually they meet together, all the big players in the country or in the market. They agree on what would be the message from all of us, and they, how can I say, they agree on that message with the government. This is what we will tell consumers. Then they start their campaigns. So I believe it's the same answer.
Thank you for your answers, Pak Badran. Really insightful and helpful.
Jadi kesimpulannya dari Pak Badran tadi itu sepertinya industri harus mengumpul dan juga bikin kampanye-kampanye yang bisa meningkatkan awareness-nya pelanggannya terhadap penggunaan sustainable material di dalam packagingnya. The gist of it is that.
Maybe we can give Pak Badran a couple of minutes to rest maybe before going to the next material, or would you like to go now? Okay. Okay, maybe we can give him a couple of minutes to give him some rest.
So 5 minutes.
Buat peserta yang mau ke toilet bisa sekarang dulu ya, sekalian sambil istirahat.
Gak tau deh. Better ke pinggirin dulu kan ya? Siniin dulu deh. Jangan di sini. Macam si Dete mau kemana ya? Boleh. Hai guys, kita lagi ini lama banget. Makasih ya, makasih ya. Iya, karena pas-pasan terus tadi saya sama dia ada anak itu kenapa sih kameranya close up apa ya?
Maaf, buat mau informasi aja buat nanti yang ke toilet jangan terlalu lama-lama ya, setidaknya 5 menit.
Kocak. Ayo, tapi aku nggak mau minum. Ada di depan. Oh, ada di depan. Boleh emang. Yang gelas aja. Bentar. Ini taruh mana ya? Ya udah sini aman kali ya. Ya udah yuk.
Maaf ya guys.
You had a chance to, I believe this is better. You don't have to see me, but you need to see the presentation. I hope you had a chance to refresh your minds. You have some space in your mind for the coming session. How much do you have now? Not too much? You need it very short? Huh? We'll see. Okay. So the next topic would be packaging safety and compliance. Let's check the agenda. What we'll be talking about. Okay, Yessi talked about it, so we won't spend much time. Roles of food packaging. Then we'll talk a little bit about risk of packaging of food. Then food contact materials regulations. We'll have an overview on the food contact materials regulation and we'll understand what we mean by that. And some word about migration testing. Okay. Rules of food packaging. I believe now you are experts on what functions does the packaging do in food. We said that packaging increases the shelf life by adding the barrier properties to prevent oxygen and water vapor transmission. It's also good for the communication because you print and your packaging is a very powerful tool to communicate with your consumers. You put your brand identity, you communicate the ingredients, you communicate the allergens. So it's a powerful tool to communicate with your consumers. And also, of course, it facilitates the handling across the supply chain, like from fork to fork, as we say. And of course, to be able to do these functions, the structure in the packaging needs to enable these functions. And we saw before with the Yessi presentation that, okay, we said we need to have communication with the consumers, then we need to have printing. This is the way we communicate. We print to communicate. We said we need to preserve the shelf life, then we need to have barrier layer or barrier material to prevent oxygen and water vapor. We need to contain the product, we need to have sealing at the end, also to prevent oxygen and water vapor as well, and also to contain the product. So these functions are enabled by the structure of the packaging material. It's very important to keep in mind that when we talk about packaging material, we talk about chemicals. At the end of the day, the packaging is or consists of chemicals, and the chemicals are usually polymers that are consisting of monomers. We said the monomers are the building blocks of polymers. You need to keep this in mind when we talk about packaging. So yes, packaging is important. We said it has a lot of functions, and the structure has to enable the functions. But the question would be, would packaging have risk on food? It's very good, protects the food, huh? But can it has a risk on food? I will take you 20 years ago, like in actually 25, so in 2005. What happened with Nestle? We had a major recall in Europe. We recalled baby milk from the markets because of one chemical migrated into baby milk, and this chemical was coming from the ink. So it is what we call photoinitiator. So the kinds of ink you can have, some of them called UV ink. This is one kind of the inks. And for this UV ink to work, to function, they need a chemical reaction initiated by what we call photoinitiator. So photoinitiator is a chemical compound that migrated into the baby food and was detected, and Nestle had to recall the product. But why Nestle had to recall the product? What is the risk this photoinitiator have? This chemical is endocrine disruptor. You know, endocrine is your hormones, where your hormones act. So it acts as a hormone. So it's as if you are giving the babies hormones externally. This will, of course, miss their biological functions. So this actually endocrine, or this photoinitiator, was like act as the male and female hormones, and of course, to give babies something that acts like a hormone externally, it's completely not correct. And the dangerous part here, like if you compare this, if we consider this as a defect, because this is not good, versus, for example, if you have a rotten, for example, or this food, like it expired. Here you cannot detect it really as a consumer. You cannot open the bag and see the chemical inside. You will never tell there is a chemical inside. But if you open versus a rotten product, okay, you open and you might have bad smell. You feel, no, I'm not gonna eat it because it smells bad. So as a consumer, you feel the problem, so you don't use it. But the problem in that case, you cannot, as a consumer, know that it has this chemical, and you would keep consuming it normally, and over a long period of time, you will get impacted by this chemical. That's why Nestle had to recall the product at that time. What was interesting here, let's have a bit close look. If we look at a classification of packaging material, we classify the packaging materials into direct contact with food or indirect contact with food. So what does it mean? Direct contact, so if this is the food, direct contact would be the first layer that physically, in physical contact with the food, we call it direct contact. Then the subsequent layers, we call them indirect. Why we call them indirect, or what is the rationale behind this classification, the basis of this classification, is the chemical migration of the substances from the layers into food. So from here we expect some migration can happen. From the subsequent layers we can expect also some migration to happen. If we don't have any barrier material in the structure, like this is porous, all of them no barrier, so chemicals can migrate from any of these layers to the food. The material, the layer that physically touch the food, we call it direct. The subsequent layers, they do not touch the food, but still chemicals can migrate from them to the food, we call them indirect. We said that the chemical we had to recall was coming from ink. In which layer you think the ink would be? Would the ink be here or the external layer? External layer, okay? So ink was here, so could migrate. This was not actually the case. Why? Because it was known at that time that materials, substances, can migrate, and to prevent this migration, we use what we call functional barrier. Not only barrier, not only barrier, we call it functional barrier. This layer is functional barrier. What do you mean by functional barrier? Functional barrier is a material, a layer that prevents the migration of chemicals to the food into quantities that would harm the consumers. This is the simple definition. So this layer, if it prevents the migration of chemicals from these layers into food in quantities that will harm the consumer, we call it functional barrier. Here I would like to make sure of very important distinction. Because when we say barrier properties in general, usually people talk about shelf life in terms of oxygen and water vapor thing. Like their focus when we say barrier is how do I protect the shelf life of the food itself from being oxidized or having moisture and so on. So this is the focus of barrier. But the focus of functional barrier is the chemical migration, not necessarily water or oxygen vapor. It's different angle of how to look at it. You can be very good at or preventing water vapor and oxygen, like you do have barrier property good enough to preserve the shelf life of the food stuff, but it might not be good enough to prevent the chemical migration. So it's very tricky that if you do your shelf life study, as Yesi was explaining how we do the shelf life assessment, we start and every month we keep taking samples, At the end of shelf life, you do your test, you smell it, you taste it, it's very good, it's very perfect. Because the barrier you use was good against oxygen and water vapor. But this doesn't mean that it can also be, or it must be, good against barrier, against chemicals. So if it's good against chemicals, we call it functional barrier. And we test it with the same concept. How? We test chemical migration every few months. We see how much was migrating. If the migration was below the limits that are safety limits, we call this material functional barrier. So, coming back to our case in 2005, it was known, the chemical migration phenomenon was known, and the usage of functional barrier was known. And in that incident, we were using functional barrier. Yet, the ink could migrate to the food. The question was how? If you use functional barrier now, how would the ink migrate? Means this functional barrier is not a barrier. No, it was a barrier, but it revealed a new phenomenon. What was called set of migration. What does it mean? The ink, if it was here, did it migrate through the functional barrier? But because of the way the laminate or the flexible laminate is structured, you wind it. You have a very long film, then what? You wind it, so it is winded like this. Then what happens here? The ink is in the outer layer, get in touch with the inner layer. So as if the ink here, when you wind, touch that layer. So it is transferred from the outer layer to the inner layer, then from the inner layer into food. So this phenomena called set of migration. This was the case that happened in Nestle in 2005 and led to recall of product from 4 countries in Europe. So chemical migration is one risk packaging can pose into food. And as we said, this, for example, is endocrine disruptor. Another risk, but now I will get you only 15 years back to 2010. It happened with Kellogg's at this time. It happened with their cereals. They had to recall the 28 million boxes because they got consumer complaints that the product tasted waxy and had bad taste. At this time, the problem was not really safety of the consumers, okay? But what migrated caused smell, so consumers didn't like it. And actually, it was waxy taste, so this was concerning. I need to, go back here to explain something first before I go. If we have this functional barrier here, we divide the layers into, this is direct contact because it is completely touching the product, so this is direct contact. This is indirect contact because still has possibility to migrate. Then whatever after the functional barrier, if you have your functional barrier, these layers would be non-contact. Why? Because there is no possibility of migration of chemicals here to the extent that would harm the consumer. So now we can classify the contacts into direct, indirect, and non-contact. So contact and non-contact. And in the contact can be direct, indirect. And measure if we have functional barrier, these are non-contact, no contact. If we don't have functional barrier, this would be indirect, which means there is a possibility to migrate. Is it clear? Any question? Good? Okay. Why I'm stressing on this point? Because let's look at the structure of this. We call it bag-in-box. So you have a carton box, outside display box, it's made of recycled carton. And then you have a bag, it was coated paper bag. And then you have the food inside. They said they had waxy smell. So with further investigation, if you look at the bag, it's a paper bag. The bag is classified as what? Direct contact. Because it physically touches the food. You have the food inside. So how would you classify the bag? It's direct contact. That touches the food. And to give the performance needed of this paper bag, they wax the bag. So they add a wax coat here to give it the needed functionality. So one possibility of why this complaint happened, because the wax layer that was used, it contained mineral oil. Mineral oil is one of the contaminants that migrated from this wax, from this paper bag into the food, which led to the consumer complaint. This is one possibility. The other possibility is, this is paper. It is known that the paper is porous. So does paper act as functional barrier? Do you expect a porous material having holes in its structure to act as a functional barrier?